Convolutional networks gave machines sight, but images are frozen in time. Language, speech, music, stock prices all unfold in sequence, where order is everything. To handle them, a network needs something new: memory. Today, the recurrent network and the clever fix that let it remember, the LSTM, start with why sequence is special. Dog bites man and man bites dog use the exact same words, but mean completely different things. The order carries the meaning. A plain network sees a bag of inputs with no sense of before and after. For sequences, that's fatal. We need a model that reads in order and remembers. The recurrent networks idea is a single loop. It processes one element at a time, one word, one time step, and after each, it passes a summary of what it's seen back into itself. That looped back summary is the hidden state. So each step combines the new input with the memory of everything before it. The loop is the whole trick. To picture it, unroll the loop across time. The same cell with the same weights is copied once per step, a chain. The first cell reads word 1 and passes its state to the second, which reads word 2, and so on down the sentence. It's not many networks, it's one network applied again and again, carrying its memory forward. That hidden state is the network's running memory, a vector that gets updated at every step. Early on, it holds the start of the sentence. Later, a compressed summary of everything read so far. When the network finally makes a prediction, it draws on this accumulated context. In principle, the hidden state lets information from step 1 reach step 100. In principle. In practice, plain RNNs forget. As that signal passes through step after step, it's repeatedly multiplied and reshaped, and it tends to fade away. The same vanishing gradient problem from our backprop episode stretched across time. By the time you're deep into a long sentence, the beginning has washed out. Short memory, long sentence, a real problem. The fix is the LSTM, long short-term memory. It adds a second pathway, a cell state that runs straight along the top of the chain, like a conveyor belt. Crucially, information can ride along it almost untouched step after step. Instead of forcing every memory through a mangling transformation, the LSTM gives it a protected lane to travel down. And the LSTM controls that belt with 3 little gates, each a tiny neural network that outputs values between 0 and 1. The forget gate decides what to erase from memory, the input gate decides what new information to write, and the output gate decides what to read out right now. Learnable valves that manage memory deliberately instead of by accident. The LSTM works beautifully but is a bit heavy, so a streamlined version appeared, the GRU, the gated recurrent unit. It merges the gates down to 2 and drops the separate cell state, making it faster with often similar results. Same core idea, gates that control memory, just with fewer moving parts. For years, gated RNNs were the state of the art for sequences. They powered machine translation, turning one language into another word by word. They drove speech recognition and text generation. And they forecast time series and weather demand markets. If data came in a sequence, an LSTM was probably reading it. But RNNs carry a fundamental limitation. Because each step depends on the state from the step before, you must process the sequence strictly in order, one element after another. You can't compute step 50 until step 49 is done. On modern hardware built for massive parallelism, that sequential bottleneck is painfully slow to train, and even LSTMs strain over very long range. Connecting a pronoun to a name mentioned paragraphs ago, the memory still gets fuzzy. We wanted a model that could look at any part of a sequence directly, no matter how far away, and process it all at once. That desire led to one of the most important ideas in modern AI. So that's the recurrent network. Loop through a sequence, carry a hidden state, and use gates, the LSTM, to protect memory over time. It taught machines to handle order, but its sequential nature and fading memory left the door open for something better. Next time, the breakthrough that replaced it. Attention, see you there.